Hello and welcome to the demo day video for CiBot, the continuous integration Slack bot we have built for our software engineering course. In researching continuous integration, we identified three key difficulties that development teams tend to face when first incorporating continuous integration into their development process, and we created CiBot to address these difficulties. The first difficulty is one that we'll call CI's inaccessibility problem. Adopting continuous integration can require a great deal of upfront work, since a strategy for committing and merging to the master branch must be formulated and agreed upon before work on a project begins. This initial overhead is lessened by tools like Travis CI, which, once configured, can automatically run builds and perform tests on a GitHub repo with each new commit to the master branch. However, configuring Travis CI itself is not always a straightforward process, and especially for novice users, it may seem like another unneeded hurdle to jump over with somewhat arcane syntax. The second difficulty is one we'll call CI's rigidity problem. In order for CI to work smoothly, each time an error is introduced into the codebase, one or more team members must shift away from their current tasks and focus on resolving the introduced problem. If the process to handle build errors is not well defined or uniformly adhered to, development can grind to a halt until the problem is fixed, or the team may ignore the failing build server and abandon CI altogether. The third difficulty is one that we'll call CI's decentralized workflow problem. While there are many tools that have been built to facilitate CI, each one typically requires its own setup, maintenance, and monitoring, requiring developers to juggle a variety of services and endpoints associated with the tools they want to use. We built CiBot to interact with the coveralls, GitHub, and Travis CI APIs in ways that would solve these three problems, opening up CI's advantages and minimizing CI's disadvantages so that development teams can get up and running with continuous integration more quickly and easily. To solve CI's inaccessibility problem, CiBot creates functional templates of the Travis YAML configuration files for popular programming languages like Node.js, pushes them to the root directory of a GitHub repo, and activates the Travis CI service for that repo. This is all done behind the scenes. All the user needs to do is give CiBot a single command and specify what programming language they will use, and CiBot takes care of the rest. To solve CI's rigidity problem, CiBot immediately sends a notification to the Slack channel associated with the project when a build failure occurs. It then prompts the team to assign one or more team members to resolve the build failure and creates a GitHub issue with these assignees. This allows for on-the-fly delegation for resolving errors, allowing the rest of the team to continue the tasks at hand. To solve CI's decentralized workflow problem, CiBot uses the channel structure of a Slack workspace to integrate communication with the coveralls, GitHub, and Travis CI APIs. For the purposes of build failures, coverage loss, and issue assignment, the team should never need to leave their Slack channel and IDE. Our first use case shows how CiBot solves CI's inaccessibility problem by abstracting the whole Travis CI setup process to a single interaction with the bot. Once we've invited CiBot to a channel, all we need to do is tell it to init Travis for a specific GitHub user and repo. We ask it to create the YAML file for us and specify the programming language we're using. CiBot then sets a default coverage threshold for our project. We'll review this in our third use case. It activates Travis CI and pushes the YAML file to the repo. A build is triggered, and when it completes, we are notified in the appropriate Slack channel of any build failures or insufficient code coverage. Our second use case shows how CiBot solves CI's rigidity problem by providing an on-the-fly method for delegating the resolution of build failures to team members. As soon as a build fails, CiBot notifies the team on the appropriate channel for the project. The team can then assign one or more team members, and CiBot will create a GitHub issue with the given title and assignees. The rest of the team is free to continue working on the tasks at hand while the assignees resolve the errors causing the build failure. Our third use case shows how CiBot solves CI's decentralized workflow problem by providing a single UI, the Slack channel, that manages the team's interactions with coveralls, GitHub, and Travis CI. When a commit is made to a project, a build is triggered in Travis CI, which uses coveralls to analyze the code coverage of the repo. If the commit causes the coverage to dip below the preset coverage threshold, which can be adjusted through interacting with CiBot, then a notification is sent to the appropriate Slack channel for the project. Similar to how CiBot facilitates on-the-fly delegation for build failures, an issue can then be immediately created and assigned to one or more team members. We hope you enjoyed the presentation for CiBot. Please let us know if you have any further questions.